Hello, my name is Mason Antis, and I'm excited to tell you about the beta decay of cobalt-60. So to begin, cobalt-60 is a radioisotope of cobalt, which is naturally found as cobalt-59. Cobalt-60 naturally beta decays into the stable nickel-60. Cobalt-60 is used to sterilize medical equipment and is also used to irradiate food as a means of preservation. A machine called the Gamma Knife uses over 200 cobalt-60 sources in a large dome around the skull to target and destroy cancer found within the normally inoperable brain tissue. Found in the middle here, you can see the full balanced reaction of cobalt. Essentially, the unstable cobalt-60 beta decays into the stable nickel-60, and by doing so, it releases one electron neutrino, which is the fundamental particle necessary in this reaction to account for a tiny amount of missing energy and momentum in the decay, and the two key gamma rays. The gamma rays are what's used in the majority of these processes, such as the gamma knife and the food irradiation. Beta decay itself is essentially the decay of a neutron into a proton, which releases one electron. This reaction is important because it is one of the only radioisotopes that produces two gamma rays per reaction, as opposed to the standard one. The two gamma rays makes this reaction incredibly efficient, and for this reason, cobalt-60 is the primary source for all gamma ray required reactions in science. The reaction mechanism for the beta decay of cobalt-60 begins with the stable cobalt-59, which is blasted with slow neutrinos, which are common byproducts in nuclear reactors, and thus becomes the unstable cobalt-60. This initial mechanism is catalyzed in cold water, which decreases the speed of the neutrons and makes the first mechanism more efficient. Some drawbacks of this reaction, though: the material does emit a strong radiation. At about 1,100 curies per gram, cobalt-60 is dangerous when exposed to. In fact, even with the proper defenses, the material can be very hazardous. This is due to the two gamma rays being emitted, which can cause some rays to synchronize and pass through thick lead. Thank you so much. I hope you enjoyed the presentation.